Okay, so hello everyone, welcome. Can you hear me? Hello.
Yes.
Okay, we'll start. Okay, we are waiting some 1 or 2 minutes. Then we'll start.
Sir, good evening, sir.
Good evening.
Sir, I have sent the code, sir.
Okay, I'll check it later and then send you the feedback. Okay.
Okay, thank you, sir.
Okay, so we will start today's session. So basically today is our fourth number of class. Okay, and after completing today's session, then we talk about the problem solving. Okay, so basically, okay, so let me share my screen. Now, can you see my screen? Is it visible?
Yes, sir, yes, sir.
Okay, so now continue. So let's. So basically today I will talk about that how we can easily remove the cloud and haze from the satellite images, as well as we talk about the TEM data, how we can easily use the TEM data and make the different types of slope map, aspect map, and hillshade map, as well as we talk about that land surface temperature, how we can easily monitor the LST or land surface temperature, as well as how we can easily monitor the urban heat island, as well as also how we can easily monitor the urban field thermal field variance index UFTVI. Okay, so we will talk a lot of time for the LST, then USI and UFTVI. So all of this step I will try to explain one by one. I hope you can easily get the idea how we can easily use the LST for making the urban heat island, and also make the UFTVI, mainly urban field thermal field variance index, UFTVI index, as well as we talk about calculate the how can we calculate the average maximum minimum any pixel. I give an example for NDVI, but using this process you can easily calculate the average maximum minimum for any pixel using the NDVI or any other types of index. You can easily use it. Okay, and we also talk about that monthly time series chart, how we can easily make the monthly time series chart. Basically, suppose you need for this specific January, February, March, December, so monthly. So in this time I give the example for evapotranspiration, but you can easily use the same approach any other conversion. Suppose you have the 8 days interval data, you can easily convert into 30 days or 1 month. You have some suppose 5 days data or 10 days data or any image collection, how you can easily convert into monthly. We also talk about this part also. Okay, so let's go one by one. We try to explain all of those things. So let's go. Just I simply open my code editor. Okay, so first of all we talk about that how we can easily remove the cloud from satellite imagery. Cloud and haze. So in this time, first of all, I simply work with the image. Suppose I simply import the Dhaka city boundary shapefile in here, and then I simply put the name, suppose RY, and I get a question how we can easily create this type of shapefile, separate shapefile. So I also show you that how we can easily create this type of shapefile after downloading the data from Diva GIS from this website. We can easily create this type of individual shapefile for Dhaka city or any other specific district or a specific province or a specific region. How we can easily create this type of shapefile. I'll also show you that further class how we can easily work with the ArcMap software and then clip this type of study area and then create this shapefile only for this study area or only for this cities or province. Further, I also try to show you the practical example. I hope you can easily got this idea how we can easily create only for the Dhaka city boundary, only for that specific city boundary shapefile, and then work with that. Okay. So in this way, simply import this boundary shapefile and put the name as the ROI. You can put any name. Further, suppose I will show you the both of images, Landsat and Sentinel, how we can remove the cloud from Landsat as well as also Sentinel. Both of images I try to explain one by one. So first of all, Sentinel. Suppose I simply search here the image collection for Sentinel 2. So now we can get, suppose here I can work for the Sentinel 2 multi-spectral instrument level on see this imagery. I want to choose and I want to work with this image. And further I will show you that how we can easily remove the cloud and haze from this satellite imagery. So basically here you can see this is the image. Here we can get all of band about this image, as well as we'll also get all of information, mainly image properties, everything we can get from here. In this time, if you want, you can see the artisan snippet. Also you can see the artisan snippet. Simply copy and then paste, or if you want you can also click on the import button, then this dataset is also imported. Suppose I just click on the import, so now this dataset is the imported and default variable name is the image collection. Okay, you can use any name. Okay, suppose I put the name is that S2. Okay, so now I simply import my image collection as well as also import this boundary. So now we are just applying the simple process to visualize this satellite imagery. Mainly we already discussed about that how we can easily filtering this image collection according to the region of interest, according to the image metadata, and according to the time period, mainly where, how and when. Okay, so let's go try to simply do that. I just take a variable, suppose I put the variable name is the image and I call my collection. So my image collection is stored in the S2, so I simply write here the S2 and I need the image for the Dhaka city, so I simply put here that filter bounds function with study area is the ROI. Okay, so S2 is my image collection. This image collection I intersect with my study area, which is ROI. ROI basically it stored at my study area of Dhaka city. Okay, further I need to define how I need this image. I need this image only for those images which will be not more than 1% cloud covered. Suppose I simply put here the filter metadata and I choose the image properties. Suppose I choose the image properties for cloud pixel percentage. So just I simply copy that cloud pixel percentage and further I just simply paste here and choose it less than 1. Okay, so it's how. And when you need this image, you can choose any time period. Suppose I put the time period filter date and put the time period, suppose year of 2020, suppose 1st January from year of 2020 or December 31. Okay, so mainly where, how and when. So in this time it filtering this image collection. Suppose I simply put at the print and then call the image and use the size function, click the run, it show me that how many image collection is available according to this condition. Here I can get the total 36 images. Okay, in this time suppose I increase this cloud level, suppose I put it at the 90%, so then you can see what happened. In this time also increase my image collection 108. And it's very important because when you want to work for the coastal area or when you work for the river bank or any other region where the all-time formation of the cloud, so then you did not find out that less than 1% image. You cannot find out less than 1% image. Then what you do? Then you need to increase this cloud pixel level. Okay, so cloud pixel percentage you have to increase the value. Then you find out the images. Otherwise it show the 0. Suppose you want to work for the coastal area, where all time information of the cloud, or river bank, where all time information of the cloud. So this type of region you put at the less than 1%, but there is no image, then you can get the totally zero. Okay, so for that you have to use at the increase the level of the cloud pixel percentage, then you can find out the image. But what's the problem when I increase this level? What's the problem? This problem is that it added the some cloudy pixel. Okay, so it's added the some cloudy pixel and also added the different types of face. So this type of problem I face when I increase these things. So now I try to show you the image at the 90% cloud level and show you the result. Suppose I create the median composite and further clip with my study area, which is RY. So now display this image. In this time you can see when I apply the median, then this size function is not work. You can see when I click in this time it shows that size is not a function. It means that size function only work for the collection. Collection means that more than one image create the collection. But when I put at the median, then this variable image is stored only for the one median composite image. So that's why it's not a collection. So that's why it shows that is not a function. Okay, because size is only work for the collection. But when I put at the median, then this variable is not stored at the image collection. It just stored it as a median composite image. So that's why in this time it shows this type of problem. Okay, the image size is not a function because size is capable only compute the collection. But when I put at the median, it's not a collection. Okay, so now we display the image and check what result we can get from here. So just I put here map dot add layer and further image and also center of this boundary shape file. So map dot center object is my RY. I put the zoom level suppose 10 and click on. So now it visualized my image collection. Now we can check what happened after adding the 90% cloud level, what image we can got from here. We check it. So let's go. It working. Some network issue. Why? Basically, it creates this type of problem for networking issue. Let me change the connection. I think some networking issue, so that's why it will be not work. Let me open the new code editor and try to work with that. So I write the code again. For some reason it not work. So now I visualize this image. And also focus the center of the boundary shape file. So now let's check what happened. So I set the visualization from here. Click on here. Suppose I set at that red, then green and blue, spacing at 98%. Further apply. Okay, so you can get this type of imagery. It's not mass cloudy. Some cloud we can also get from here. Okay, also increase, suppose 99%, and then try to add. So you can get this type of cloud. You can see. We can get this type of cloud. And I also want to import the visualization. So for that, click on the import and copy and paste after the object name. So now it will be set with the visualization. Put the layer name cloud image. Okay. So now here we can get this type of heads as well as we can get this type of cloud. So in this time, I want to remove this type of heads as well as also remove this type of cloud. Okay, so that's why we can get the very clear satellite imagery. Okay. So now how I can do that? In this time, we are also use the cloud marks band function. So here you can see in this Sentinel 2 imagery, it also provides the one kind of band. This band called the cloud marks band. So here you can see that. So this is the band name. Okay. Cloud marks QS60 band, and now you can see it added the new update empty after February 2020. So it not work, I think, for that 23 or 24 we have to use the new code. Okay, so it's a new updating, they're also added in here. So okay, further we discuss about the later when you talk about the 2023 or 24, then it will work, but in this time we talk about the 2020, so that I hope it will work. Okay, so in this time here you can see this is the band QS60. Okay, and QS60, this band have a 2-bit, barely bit 10 and bit 11. Okay, and bit 0 to 9 it totally unused, and bit 10 we get the two signal, one is 0 and 1. 0 means no cloud and 1 means cloud present. Also you can see bit 11 mainly cirrus cloud, 0 means no cirrus cloud, and 1 means that no cloud present. Okay, so in this time we are working with this band. Okay, so first of all we have selected this band QA60, and further we select the bit 10 and bit 11. Okay, and from the bit 10 we select the bit 0 signal, and also bit 11 select the bit 0 signal, which is including the clear condition or no cloud condition. Okay, and we do it using a function. So in this time I simply copy this band name, and I need to create a function. So for that I just take a variable. Suppose I put the variable name is that cloud bit max. Okay, equal sign function keyword. Okay, I put the element name, I take only for the one image, and using this image I will do all of those things in my argument. In this time my first argument is that I take a variable QA and call this image and select this band QA60, and QA60 have a 2 bit 10 and bit 11. So further I take the variable, suppose cloud bit max, and now for I set the 1 less than bit 10. Okay, so basically this is a syntax for selecting the bit number. All time you put the 1 less than and then put at the bit number. Okay, and I'll select another bit number. Suppose I put the cirrus bit max, I take the another variable and set 1 less than bit number for 11. Okay, bit 10 and bit 11 we simply store it in the two variable, and further we are just set the condition bit 10 equal to 0 and bit 11 equal to 0. For doing this thing, just take a variable. I put the variable and suppose max equal, I call the QA. So basically this is the band QA60 band stored at the QA, and now I want to connect with the bit 10. So for that use at the bit wise end. Okay, wise end. Okay, so basically this function connecting the bit number, I simply copy the bit 10 and paste here and set equal to 0 signal, and further use at the end function and call the QA and connect with the bit number. So use at the bit wise end function and call the cirrus bit max equal to 0. Okay, so this is my condition. Okay, so my first condition is that I have to select the QA60 band and also store at the bit 10 and bit 11 in a variable, and further I connect the bit with my band QA60. So I call the QA bitwise end for connecting with the bit number 10 and set equal to 0, and do for the same things for the cirrus bit max. Okay, so equal to 0. So now I want to return what I return from here. I want to return this image update max using a condition. What is my condition? My condition is that I simply copy and paste here. So I want to update this image using this condition, and this condition store it in the max variable. So I put here the max. Okay, so now this is my function. Okay, this function help you to remove cloud and haze from your satellite imagery. So now this function I want to connect with my image collection. So this is my image collection, I need to connect with that. So I want to create another layer of image. So I simply copy and then paste here, and I simply put the collection. So basically when I put after median, I cannot add it. After median you cannot add it, because when I put the median, then it's not a collection, it's just a single image. So I have to use the map function before median. Okay, before median I have to use here the map function, then it connect with my collection and work with that. So I simply copy the function variable name. My function variable name is the cloud bit max. I simply copy and then paste here. Okay, and further suppose I want to suppose image, I put the new variable name image free, copy and paste here, and further I want to run the code and check what's happened for the after adding the function of the cloud bitmaps, what happened. So now click on run. Now we can get the two layer. One is the cloud image, another is the cloud free image, which is we add the cloud remove function, mainly cloud marks function. And so this is the cloud image, basically this layer. And further I want to add the visualization, so click on here and then before red, green and blue. Custom spacing 98%. And further
Hello?
apply it. Yeah, please.
I have just one question.
Yeah, please.
Because in the timetable it is written 11 a.m. in US, right?
Okay, kindly again explain, please.
No. My question is, in the timetable for the time it is written 11 a.m. in the US. Okay.
Okay, which one not clear?
No. Like, let me. Okay. You wrote like a different time zone in. Let me message you.
Okay, if possible, you can simply write your question. Your voice is not clear. Kindly write. Write your question. Okay, so now here you can see we can get the very clear satellite imagery. So you can see that this is the first image. We can get this type of haze, okay, cloudy pixel, and also you can see when I apply the cloud max function, then we can get this type of imagery. So now I can check about the difference between the two images. After adding the cloud max function, we can get this type of imagery. Okay, very cloudy and haze, we can get this type of imagery. And when I apply the cloud max function, then we can get with this type of clear satellite imagery. So now I try to import this visualization parameter again in my code, and then copy this variable name and paste after the object name. And also put the layer name. Suppose it's a cloud free. Okay. So now you can see what is the difference. When you apply the cloud marks band function, then this type of unnecessary cloud or haze will be removed from here. Okay, but you can say first time I increase the 90% cloud level, but don't add the cloud remove function. Then we can get this cloudy image. But in the second time here you can see I create this function, and this function I add with my image collection using the map function. I put the function variable name, and I also use the same cloud level, but in this time there is no cloud. This is the power of function, cloud marks band function. It removes all of unnecessary pixel from your satellite imagery. So that's why now we can easily get that very high low cloud imagery. You can easily get totally clear imagery. You can easily get in your coastal area or river bank or any other place. And when you increase this level, it also increase your image collection. Okay, so now come back the question. Yeah, please. Okay, IN timetable is written 11 a.m. Where you get it? Okay, so I already published this timetable, our class schedule. You can easily get it from our Google Classroom. Okay, let me check you that again. Just a minute. So you can easily get this timetable. Yeah, you can see this is the time about the India. Okay, so I already published all of information when the class will be start and every country. Okay, you can easily get this timetable in our Google Classroom, as well as I already defined about that. You can see
No. See, you have written 10 a.m. USA, United States.
Okay, United States. Okay, let me check. Okay, United States. Okay, so is there any mistake in here or not? 9
Yeah,
p.m.
because
Yeah,
I think you like because it's 10:45 here, right?
yeah,
So
yeah, yeah. 9 p.m. to 9 p.m. Bangladesh to United States. What's the difference? Okay, it's showing that 11 a.m. USA, mainly Washington DC time. 9 p.m. Bangladesh time is 11 a.m. in Washington DC USA. Okay, so for Bangladesh 9 p.m. for okay, I think where are you from? Are you USA or India now? Okay, okay. So is it wrong time show for that USA? Okay, so 9 p.m. for Bangladesh GMT plus 6.
okay, because you wrote it 11, so I came up here because this thing happened yesterday as well.
Okay, so now where are you from? Are you India or USA?
So I'm here for like 2 months.
Okay, okay,
So just for okay.
okay. So okay, I will get this time from where 9 p.m. Saturday in Bangladesh is 11 a.m. Saturday in Washington DC. Okay, but India time is the okay. So I already published all this team in here. Okay, okay, okay. So now continue the class. Okay. Okay, so here you can see this is the process to removing the cloud and haze from the satellite imagery. Okay, so in this time we talk about the Landsat imagery. Suppose for the Landsat image, how I can remove. So same process you are also applying for the Landsat imagery. So I try to open a new code editor. So in this time I talk about the Landsat imagery. If you want, you can simply search here for Landsat, or if you want, you can simply go to the browse data catalog and open this image collection from here. Suppose click on the Landsat. And I want to work for the Landsat 8. So click on here the Landsat 8. And basically in this time, yeah, I work for the surface reflectance. Basically, surface reflectance is also used for LST monitoring or land surface temperature monitoring. Okay, so here you can see in this time, this is our image collection. So I simply copy the snippet from here and then paste in here. I just give a variable name